In 1904, on the Canadian side of Niagara Falls, men stood in spray so thick it settled on their hats and shoulders like cold rain, and they built arches where common sense said there should have been none at all. Not a decorative promenade in a city park, not a little masonry bridge over a stream, but a line of stone-faced concrete spans, nearly 300 feet in total, laid out at the very edge of the Niagara Gorge, beside a river already being forced into a new industrial shape, and beside a waterfall whose force could drown shouting, "Shake timber," and turn one mistake into a funeral by nightfall. This was a physical problem. Before electricity could be sold, before turbines could spin, before Niagara could be turned from wonder into power, someone had to make water go where engineers wanted it to go. That meant cutting a forebay out of the river's edge, walling it, bridging it, screening it against ice, and tying it to a powerhouse, a wheel pit, and a tunnel driven deep through rock. It meant building a permanent heavy structure on the lip of a violent river, with picks, drills, horse carts, timber falsework, steam pumps, lantern light, and nerve. The question was never simply whether the design worked on paper. The real question was harder. How did workers actually make it stand? That question mattered because Niagara, at the turn of the 20th century, was no longer only a spectacle. It was a contest. Cities wanted power, investors wanted returns, engineers wanted proof that alternating current could be generated on a scale the 19th century had barely imagined. Buffalo wanted electricity for industry. The park commissioners on the Canadian side, expected to preserve the landscape and pay their own way, wanted revenue from the very river they were supposed to protect, and so the falls became one of the places where the modern world stopped admiring nature from a safe distance and began to reorganize it. The Canadian Niagara Power Project grew out of that moment. Rights were secured in the 1890s, deadlines were promised and missed, local patience wore thin. On the American side, hydroelectric development was already proving what Niagara might become. On the Canadian side, delay was politically costly, but technically useful. Every extra year allowed designers and financiers to learn from earlier stations, from transmission problems, from machinery still evolving almost by the month. By the time construction truly advanced, this was no longer a speculative dream, it was an enormous wager on an electrical future. And like most futures, it would be built first by men with shovels. If these kinds of stories matter to you, the stories where the modern world is revealed not as abstraction, but as labor, skill, and risk, subscribe. Because places like Niagara were not built by metaphors, they were built by hand. Construction began in 1901, and from the beginning, the task had to be broken into several brutal realities that all had to proceed together. There would be a cofferdam to hold back the river. There would be a forebay cut into the edge of the site so water could be admitted in controlled form. There would be submerged arches and screens to filter debris and ice. There would be a powerhouse on the surface. Beneath it, a wheel pit dropping toward the turbines. Beyond it, a tail race tunnel more than 2,000 feet long, carrying spent water back out below the falls. None of these pieces could wait politely for the others. They were interlocked. The whole machine had to be imagined before any one part could be finished. So before the arches rose, the river first had to be pushed aside. A great temporary cofferdam was built out into the Niagara, using timber and heavy stone to create a barrier against the current. It was not elegant work. It was wet, repetitive, punishing labor, the sort of labor that consumes men's backs before it earns them any glory. Leakage was inevitable. Steam-driven pumps had to run to keep the excavation workable. Mud collected everywhere. Timber had to be set, braced, reset, and watched. Every man on that line understood that the river was not defeated. It was only being delayed. The cofferdam remained for roughly 2 years, long enough to turn part of the river's edge into a raw, exposed worksite. Once the water was pushed back, crews began excavating the forebay. They dug it down to about 14 feet, hauling spoils away by horse-drawn carts, often 1 cubic yard at a time. It is easy to say that now, 1 cubic yard at a time. But that phrase contains the real pace of construction before diesel fleets and hydraulic excavators made such work seem routine. It means animals straining into harness, wheels grinding through ruts, men with shovels loading, scraping, and cursing in cold mist. It means the project advanced not in sweeping cinematic gestures, but in thousands of stubborn repetitions. Around the forebay, quarried stone walls rose in heavy courses. Limestone from Queenston and other local materials had to be brought in, shaped, laid, and fitted into a place where water pressure, frost, vibration, and time would test every joint. The forebay was not just an opening in the riverbank, it was a regulating chamber, a threshold between wild flow and industrial discipline. Water would pass from Niagara into this man-made basin, and from there into the plant's intake system. But Niagara was not only water, it was also ice. Anyone who planned to harness the river had to solve the seasonal violence that came drifting down from Lake Erie. Chunks of ice could jam an intake, batter gates, disrupt generation, and endanger the whole enterprise. So the design included submerged inlet arches and a sequence of barriers to manage what the river carried. There were booms and gratings, later steel racks and curtains, and permanent bars at vulnerable points. But even before metal screens became the last line of defense, the logic of the intake was arch, opening, and controlled passage. Water could be admitted, ice had to be delayed, diverted, or shed back into the river, and this is where the arches entered the story. The bridge across the forebay, with its series of concrete arches faced in stone, was not the star of tourist postcards in the way the suspension bridges and steel arches over the gorge were. It did not proclaim itself with slender iron ribs or impossible suspension cables. Its power was quieter. More geologically, it lay low, heavy, deliberate, built to seem almost inevitable against the landscape. 5 spans carried roadway and rail access across the forebay, totaling roughly 90 meters, just under 300 feet. To modernize, that may not sound outrageous. But the feat is easier to underestimate precisely because the bridge sits close to the ground and borrows the visual language of old masonry. Its strength does not shout, it presses downward and outward. It relies on mass, on shape, on geometry, on each curve forcing load into compression. That did not make it easy. Concrete at the turn of the century still carried an air of novelty and argument. Engineers believed in it, contractors advertised it, critics distrusted it. The material was changing construction, but standards were not yet settled in the way later generations would take for granted. And here, on the lip of Niagara, workers were being asked to place it into forms that had to hold their line, cure properly in a damp, unstable environment, and endure both traffic and waterworks conditions for decades. Timber centering had to be framed for each arch. Formwork had to be set true. Concrete had to be mixed, moved, placed, and tamped before it began to stiffen. Stone facings had to be aligned so that the finished bridge belonged visually to the grand Romanesque language of the generating station beside it. No one on that job had the luxury of forgetting what a misread level or poorly braced form could do. Wet concrete is patient only for a little while, then it hardens into your competence or your mistake. To understand the project, it helps to leave the surface and go underground, because the arches above the forebay were only one visible fragment of a much greater physical undertaking. Beneath the site, the tail race tunnel was being driven through the earth to return water from the turbines back to Niagara, below the falls. It would run about 2,200 feet. It would sit deep underground, roughly 180 feet below the surface at parts of its course. It would have to carry immense volumes of fast-moving water, and it would be excavated the old way, with blasting, mucking, lining, and alignment so careful that men trusted wires and plumb bobs in darkness to meet other men coming from the opposite direction. The tunnel work began by sinking a shaft roughly midway along the intended route. From there, crews dug in both directions, one toward the future wheel pit, the other toward the river outlet, while another party worked inward from the mouth. Small dynamite charges broke the rock, men cleared spoil, timber held sections where the ground could not yet be trusted. Brick and concrete lining followed. The tunnel was arched because the arch was still one of the great answers to gravity and pressure. In later accounts, one of the proudest details was that the headings met with near-perfect alignment, guided by suspended wires and meticulous surveying underground. It sounds almost serene in retrospect. It would not have felt serene then. Imagine the shift. Lantern light in the air is already made bad by powder smoke and wet shale. Dripping walls, mud underfoot. The concussion of blasts arriving through rock before the dust had settled from the last one. Men straining on bars and shovels in a place where day and night meant nothing except the hour the whistle sounded above. Evening crews fitting arch keys into the tunnel lining as the structure slowly took shape. Water always threatens entry through cracks, seams, fissures, weaknesses not yet visible until they open. At one point, excavation of the wheel pit above and the tunnel below weakened the remaining shale so badly that water from the upper work began leaking into the tunnel. The solution was not dramatic, it was difficult. The roof of the tunnel had to be timbered, and parts of the wheel pit later supported by cast iron struts. This is how real construction proceeds, not by pure triumph, by correction, by discovering where the earth refuses your first idea and building a second answer before the first failure becomes a collapse. And always, at the center of it, the workers. The records preserve the company names, the engineers, the power output, the dimensions, the milestones. The workers come to us more faintly. We see them in photographs, standing in hats and coats beside excavation faces or on timber staging. We see horse teams in the forebay. We see cut stones stacked in courses. We see drill holes, carts, derricks, pipes, and bricks. Sometimes we get a flash from outside the official record, a cemetery note, an undertaker's line, a local diary. Across the hydro works rising around Niagara in those years, men were struck by buckets, pulled into machinery, felled by derricks, crushed, thrown, or lost to falls into pits. Many were immigrants. Many appear in the record only at the moment they vanish from it. That is the true proportion of such projects. A station can live for a century. A laborer can disappear in an afternoon. So picture one group, not as invented heroes, but as the kind of crew the site plainly required and the records plainly imply. A carpenter from town, good with false work and wet forms. A quarryman used to handling stone with care because a slipped block has no conscience. Tunnel men, blackened with powder dust. Teamsters handling nervous horses at the edge of excavation. Bricklayers in the tunnel lining crews. Rivermen and labourers from Italy, from Poland, from Hungary, from the local district, each one carrying his own language into a place where most commands reduced to gesture, tone, and urgency. Their hands would have been swollen in winter, their boots soaked through, their shoulders chafed from carrying tools and timber. They would have known the sound of a load shifting before they saw it. They would have slept with blasting still echoing in the body. Above them, the powerhouse rose. Its exterior was deliberately handsome, rusticated stone and arched windows, because this was not just an industrial shed. It stood in a park landscape where appearance mattered politically and culturally. The park commissioners did not want the Canadian side of Niagara surrendered entirely to ugly utility, so the building had to perform two tasks at once: announce power and disguise its violence. Inside, however, it was all weight and mechanism. The first completed section, nearly 296 feet long when the station opened, housed huge generators linked by vertical shafts some 130 feet down to the turbines in the wheel pit below. Those shafts were massive, each on the order of 90 tons, supported by oil-fed and water-cooled bearings. The machine hall above, the pit below, the tunnel beyond, the forebay before it, and the arch bridge crossing that forebay were all part of one integrated organism. Even the question of wires revealed the politics of the place. The Commission had no desire to litter the park with intrusive overhead lines, so transmission arrangements had to respect scenery as well as engineering. A separate transformer house and underground ducts helped hide part of the machinery of electrification from the tourist eye. This, too, is part of the labor story. Modernity likes to conceal the very systems that make it possible. It hides cables, pipes, drainage, substructure, intakes, and tail races. It hid them then, it hides them now. Meanwhile, the economics pressed on everything. Delays had already damaged public trust. Competing developments on both sides of the falls were advancing. The technology of alternating current transmission was moving fast, and every investor wanted assurance that today's expensive marvel would not become tomorrow's obsolete apparatus. Yet the delay also meant that by the time the Canadian station came fully into service, it could incorporate lessons learned elsewhere. Three-phase power, more efficient for transmission and distribution, gave the station a broader future. This was not power for a handful of lamps by the water, it was power for a region. That regional consequence is what raised the stakes of every pick stroke at the site. Buffalo's factories and industries needed energy. Niagara itself was becoming an industrial corridor, not merely a destination. Power could now cross distance. The old limitation of local water wheels and tiny mill races was giving way to a new geography in which a waterfall could feed an electrical network far beyond where its spray could be felt. Men standing ankle-deep in mud beside the forebay were helping build an economy they would never see whole. That is another truth of labor history. Workers usually inhabit only the fragments they can reach with their bodies. Someone else names the age. By early 1905, the project had crossed from construction into operation, though work would continue as later units and expansions were added. Official openings came before absolute completion, as they so often do in big infrastructure. On July 27, 1905, the station went online in earnest. The first generators began their work. Water entered through the controlled reaches of the forebay, dropped through penstocks, spun turbines below, and returned through the tunnel to the lower river. A sequence of spaces that had existed first as mud, timber, and excavation became a machine for turning gravity into current. What changed? Almost everything. The Canadian side of Niagara acquired its first major hydroelectric generating station. Power flowed to industrial users in the region and beyond, strengthening ties to Buffalo and the cross-border manufacturing economy that would define the area for decades. The park commissioners, who had sold water rights in part to sustain the landscape they managed, were now living inside the contradiction they had created. Niagara, preserved as scenery, and Niagara consumed as power, both at once. The river still thundered for visitors, but behind and beside that spectacle was a hidden industrial anatomy of forebays, wheel pits, shafts, intakes, and discharge tunnels. And the arches remained, not the most famous arches in Niagara, not the vast steel ones that later came to dominate the postcard view, but these lower, quieter spans at the power station's forebay did something almost more revealing. They show how infrastructure often tries to naturalize itself, to sink into the landscape until it seems it has always been there. They carried roadway and rail traffic. They crossed the man-made basin feeding one of the most important power works on the Canadian side. They stood not by denying the river's force, but by accommodating it, channeling it, and making its violence legible to engineering. Time, of course, altered the place. The station expanded. More generators were added. Ownership patterns changed. Private hydro gave way, in much of Ontario, to broader public systems. Older frequencies such as 25 Hz, once perfectly suited to heavy industrial loads, became remnants in a world standardized differently. Eventually the Rankin station ceased generation after more than a century of service. But the fact that it could last that long tells its own story. These people were not building for a season, they were building for permanence, or as close to permanence as a river edge ever permits. In the 21st century, visitors can walk through the restored Niagara Parks power station and descend into the tail race tunnel. They can move through the same long underground passage that once returned used water to the river. They can stand at the outlet and look back toward the falls. They can see the four-bay bridge, the stone, the industrial geometry, the proximity of beauty and mechanism. If you have ever done that, or if there is a forgotten bridge, tunnel, mill, powerhouse, or retaining wall in your own town whose builders vanished from memory long before the structure did, tell us about it in the comments. Those places deserve witnesses too.